So we're continuing on with our circle exercises, and our next exercise is number 8 from the handout. We're looking at a circle with this equation, x squared plus y squared equals 16. And we want to know what are the x and y intercepts and a whole bunch of other information. Now, before we go ahead and start A, you should be able to just look at this equation now and see that as it's a circle centered at the origin, 0, 0, and the radius is going to be square root of 16, which is 4. So radius 4 centered at the origin. Now let's go ahead and find the x and y intercepts. You know, if you know that, if you can just write down what the intercepts are, it's okay to do that without doing any calculations. I'll go through the calculations just so that we see the calculations confirm what we might already suspect about the intercepts. So let's just maybe do x intercepts. To get x intercepts, we have to set y equal to 0, right, to find the x intercepts. So I'm going to take that equation and write x squared plus 0 squared equals 16. X squared is equal to 16. Now here I have to, when I take square roots, I got to be concerned about the plus or minus sign, right? There are two square roots. I know in an earlier video, finding the radius, I just took the positive square root because the radius has to be positive. But here, x could be positive or negative, and so we need to consider both square roots, and we got two x-intercepts here. Let's see if I have room to write 4, 0, and negative 4, 0 are the x-intercepts. For y-intercepts, set x equal to 0. So I'm going to take my equation and write 0 squared plus y squared equals 16. So x equals 0 in the original equation. Y squared is 16. Looks kind of like what we just did, right? Y will be plus or minus the square root of 16. So y is plus or minus 4. So we have 0, 4, and 0, negative 4 as the y-intercepts. Okay, let's go on to part B. So what are the coordinates of all points on this circle for which y equals 3? We can take that same equation, x squared plus y squared equals 16, and I'm going to plug in y equals 3. So I get x squared plus 3 squared equals 16. X squared plus 9 equals 16. And now I got to subtract 9 from both sides. X squared is going to be 16 minus 9 is 7. Here I get x is equal to, take square roots again, plus or minus the square root of 7. Now that won't simplify as far as the radical is concerned, so we can just write this as square root of 7 comma 3, sorry, not 0, it's not an intercept. But we also have negative square root of 7 comma 3. Those are 2 points where on the circle where y is equal to 3. Now, what if we were looking for points where y is equal to negative 3? Same equation. I'm going to plug in negative 3 for y. I have to write that as negative 3 in parentheses squared. And when I square that negative 3, I'm going to get a positive. So I end up with x squared plus 9 equals 16 again. It's just like what we saw before. I'm going to have x squared equals 7. X equals plus or minus the square root of 7. And so I get 2 points again. But now this is with y coordinate -3. So I have square root of 7, -3, and negative square root of 7, -3. So we got 2 points where y was 3, 2 points where y is -3. Let's do this again with finding all points for which x is equal to 1, same circle. So now I'm going to plug in 1 for x and solve for y. So it's the same kind of thing, right? I got 1 plus y squared is 16. I got to subtract 1 from both sides. Y squared is 15. So y is equal to plus or minus the square root of 15. And I don't think I can simplify that radical. 15 is 5 times 3. That's the only way to factor 15. I don't have a perfect square factor, so that's it. That's a simplified radical form. And now x was 1, so y could be positive square root of 15, and x is 1, comma, negative square root of 15. They're the 2 points from part D. And it keeps going. Part E is what if x is equal to -1, so same equation. And when we plug in -1, we got to be aware that we're taking -1 in parentheses squared plus y squared equals 16. And kind of like what we saw happen with the y's, a similar thing is happening here. We get positive 1 plus y squared is 16 because the negative number squared is positive. And so we end up with that y squared equals 15 again, even though we plugged in a different value for x, right? We got y equals plus or minus the square root of 15 when we take square roots. So here our x value is -1, positive square root of 15, and -1, y could be negative square root of 15. And let's see, one more part, F here. Find all points on the circle for which y is equal to y is equal to 5. All right, well, let's plug in. Let's see, x squared plus 5 squared. Oops, that wasn't my typo. I should have wrote 16 there, right? So the equation is x squared plus y squared is 16. When I plug in y equals 5, I get x squared plus 5 squared equals 16. X squared plus 25 equals 16. Now I have to subtract 25 from both sides. I'm going to get x squared equals -9, or x equals plus or minus radical -9. This is not a real number. We would get an imaginary number trying to take square root of a negative here. But when we're graphing equations, imaginary numbers never show up on the graphing. So there are no points on the circle with y equal 5. Now that's the end of the exercise, but what I want to do before we move on is I want to sketch the graph of this circle and actually look at where all these points lie on the graph, just to bring it to life a little bit. So this is x squared plus y squared equals 16, which, even without all these calculations, we could have graphed this circle pretty easily because we know the center is at 0, 0. The radius is 4, the square root of 16. So if we go 4 units to the right, 4 units up, now this is actually the point 0, 4. This is the point 4, 0. Go 4 to the left, negative 4, 0. Go 4 down, I get 0, negative 4. Those are my 4 intercept points, which we found right at the beginning. Then we found some more points, right? We found this square root of 7, 3, and negative square root of 7, 3. Square root of 7, I checked on my calculator. Square root of 7 is about 2.6. So I'm gonna try to plot these points here. Here's 2.6. 2.6 about halfway in between 1, 2, 3. There's a point with coordinates square root of 7, 3. And if I do negative square root of 7, 3, that's about negative 2.63. It's over here. Then we got square root of 7, negative 3, negative square root of 7, negative 3. So we actually got points with square root of 7, negative 3. We got a point down here. And we got a point over here, negative square root of 7, negative 3. That was like in part C, right? In D, we got 1 square root of 15, 1 negative square root of 15. So I need a decimal for square root of 15, so I could plot that, and I checked on my calculator, that's about 3.9. So I got 1 square root of 15, 1, 3.9, 1, 2, 3.9 is way up there. 1 square root of 15, and then I had 1 negative square root of 15, positive 1 negative square root of 15. So 1, 2, 3, 3.9. And at the top of this page, we found negative 1 square root of 15 and negative 1 negative square root of 15. Now I'm running out of room to label these. That was negative 1 square root of 15. And so again, we didn't really have to plot all those, but I just wanted to just see that all those funny numbers we came up with identify points that are directly on this circle. And part F, where we wanted to find points on the graph with y coordinate 5, well, y is equal to 5 way up here. Y coordinates of 5 go across this horizontal line. Well, of course there are no points on the circle with y equals 5 because we've gone beyond the radius of that circle. And so again, if we had this picture ahead of time, we wouldn't have even had to do any algebra for part F. We could have just said, no way, there couldn't be any points. So I hope this picture brings some of these values to life a little bit that we got as points on the graph of this circle. Okay, now in this segment I want to do one more problem. And number 9 exercise. It's what are the coordinates of the points of intersection of the line y equals 2x with the circle x squared plus y squared equals 25. Now, this is really just an algebra problem. You don't need to graph. So, but I'm going to draw a graph again, because I think the graph will help bring this to life a little bit. And it's not too hard to sketch the graphs here. X, Y. I'm just going to use my standard scale, so each square is 1. The line y equals 2x, that's a line, it's like y equals 2x plus 0. That's a line with y-intercept 0, slope 2. So it goes through 0, 0. And if I go up 2 over 1, up 2 over 1, up 2 over 1, I get more points on that line. So whatever technique you're familiar with, you should be able to draw a graph of y equals 2x. That's a straight line. All right, now the other equation we know, x squared plus y squared equals 25, is a circle centered at the origin of radius 5. So it's going to go through this point, right? It's easy to find the intercepts because our center is at 0, 0. So I'm just moving out 5 units along each axis, and then I'm not going to go through the detail of calculations we went in the previous problem. I'm just going to do my rough sketch of a circle here. Okay, a little lopsided, but that'll do. And so we're trying to find the coordinates, the points of intersection of the line in the circle. So we're trying to find the coordinates of this point and this point. Can you see there are 2 points we're looking for here? And it's not so easy for me to read off those coordinates from my picture. In fact, they might be a little bit off because my graph is kind of lopsided. So we're going to do the algebra of this. We're going to go through algebra to figure out the coordinates of those points. Let me recopy the equations. X squared plus y squared equals 25, and y equals 2x. To find the coordinates of those points of intersection, we're going to think of this as a system of 2 equations in 2 variables. And I think you've probably solved systems of equations before, maybe systems of linear equations. And there are different kinds of techniques you can use. Probably the most useful technique in algebra for solving a system is a substitution method. I'm just going to label these equations 1 and 2. So I'm going to just recopy equation 1. And I'm going to use equation 2 because I have y isolated here. Equation 2 is telling me that y can be replaced with 2x anywhere in this problem where we're solving the system. So I'm going to take equation 1 and I'm going to make that substitution where I'm going to replace the y with 2x. So I recopy x squared. So let's maybe say the substitution from equation 2 is where we're getting the idea from. Y can be replaced with 2x. So I have x squared plus 2x. Now I have to write that in parentheses squared equals 25 because the 2x, that entire quantity, has to get squared since it replaces y. I have x squared plus 4x squared equals 25. And maybe I should say here, notice now that I only have one variable, so I can solve for x. The point of substitution is to get an equation with one variable that we can solve. I'm going to combine these two like terms. 5x squared is 25. divide both sides by 5. Now, I like that 25, but I'm going to end up with x squared equals 25 divided by 5 is 5. So x is equal to plus or minus the square root of 5 when I take square roots. I have two possible values of x, and so I should say x equals square root of 5, or x equals negative square root of 5. And then I have to find the corresponding y in each case. And I go back to one of the earlier equations. I can go back to equation 2, the y equals 2x equation, and plug in y is equal to 2 times square root of 5, because it's 2 times x, that x value. So the point would be square root of 5 to square root of 5. And my other one is, I get another point when I plug in the negative value of x. Y equals 2 times negative square root of 5. So I'm multiplying here. I get y equals negative 2 square root of 5. Or a point with coordinates negative square root of 5, negative 2 square root of 5. Both coordinates are negative there. So my answer, I'm just going to recopy up here. I got square root of 5, 2 square root of 5, and negative square root of 5, negative 2 square root of 5. There are two solutions. There are 2 points, and they correspond to my 2 points on the graph. You know, that square root of 5, square root of 5 is about 2.2. So 2.2 up to here, that matches up with square root of 5. The coordinates of this point are square root of 5. 2 square root of 5, 2 times 2.2 is like 4.4. So the y value there should be about 4.4. My other point has both negative coordinates, negative square root of 5, negative 2 square root of 5. So I kind of like how I can see the meaning of the answer we got here on my graph. But the algebra of the solution is down here at the bottom, where we went through this substitution method to solve.